Welcome to Baker Tech Talk. I'm Mike Baker. EVPN-VXLAN topology is often seen in modern data center network architectures. The purpose of this video was for me to work through an EVPN-VXLAN with MLAG configuration using virtual Arista switches. This is not a full explanation of EVPN-VXLAN technology. You can find a few great explainers on YouTube and in my notes below. This is a practical exercise to configure, test, and troubleshoot EVPN-VXLAN in a lab environment where you can see the actual configuration and function. I am new to EVPN-VXLAN on Arista, so feel free to leave suggestions in the comments below. Thanks for watching. Our next step will be to configure MLAG, both the pairing between leaf 1 and 2, and the MLAG connections themselves between hosts A and host B back to the leaf 1 and 2 switches. So let's talk about that for a moment. At the root of MLAG, we're going to need the two leaf switches to have a channel on which they can communicate in regard to the MLAG configuration and state. That's going to happen on its own VLAN, and if you look at the Arista MLAG documentation, they suggest using VLAN 4094. So we'll create VLAN 4094 on both leaf 1 and leaf 2 switches. We will allow that, or we'll create a trunk on port channel 1 using these E3 and 4 interfaces between the two leaves. Tie that up in a port channel. We're going to put the trunk, make a trunk group for VLAN 4094. The trunk group will be assigned to port channel 1. We'll also give layer 3 addressing to the VLAN 4094 layer 3 interface, and I've laid out the addressing here. We'll use this 999/31 subnet, so .0 on leaf 1, .1 on leaf 2. This will allow the two leaf switches to negotiate the MLAG and to exchange state information. So I guess we can get started. Let's flip over then to the config. So let's get on leaf 1. Actually, why don't we're going to do, some of it's common to both, so let's just do this. So it's on all 4 of these leaves. So we're going to create VLAN 4094 as a first step. So VLAN 4094, we'll give it a name, and we'll call it MLAG peer. Well, we'll just call it MLAG. Then we'll go ahead and, as I said, we'll need to tie together the two, leaf 1 and leaf 2. So let's start building this the two Eths together. So Ethernet 3 and 4 will be joined to port channel 1. So let's set that up now. That's true on both of these. So yeah, we can do all 4 at once. So we will do interface ETH 3 and 4, and we're going to just do channel group 1, mode active. So we're going to set up these two ports on each to negotiate LACP actively with the other side. So that's underway. Now we can change to interface port channel 1. So in here, we're going to make this a switch port mode trunk. And we're not going to restrict that at all. We're going to, I skipped a step. We're going to want to go back to, let's just go back to VLAN 4094. Yeah, I'm remembering we're going to create a trunk group, so we're going to do that here. So trunk group MLAG peer, let's call it. So now we have VLAN 494 is included in trunk group MLAG peer. Now let's go back to interface port channel 1, and we're going to do switch port trunk group MLAG peer. So now we've tied the VLAN 4094 to that port channel by the trunk group. One other thing, since since we're now limiting where the 4094 VLAN can go, and really it's just between leaf 1 and leaf 2 over this port channel, we don't really have a need for spanning tree then. So we can also say, well, sorry, we don't have a need for spanning tree on VLAN 4094. So we can get rid of that here, 4094. Here we go. So interesting how it's, I guess because I'm still in port channel 1 exit, maybe try it here. Sorry, no, spanning tree, VLAN 4094. Okay, there we go. I think because I was still in port channel, it wasn't going to work. All right, so I think we have the prep work done. 4094, well, let's do, let's just do show run. We'll take a look at this quickly. All right. So on each of these, we've got VLAN 4094 belongs to the trunk group MLAG peer. Port channel 1 is set up as a trunk and belongs to trunk group MLAG peer. Then Ethernet 3 and 4, we could see are both set up in channel group 1, so they belong to port group 1. So that should be off and running. Why don't we take a quick look? Let's do show LACP peer. This is one option we have. So we can see that this is all up and running. Actually, let's drop out of here for a moment. So if we look at this, show LACP on number 1, we can see ports E3 and 4 are tied together, and these states are all just what we're looking for. We can also do show port channel. Well, just hit enter. We'll see at this. We'll see them all. So port channel 1, active ports E3 and 4. So there we go. Let's come back to the diagram for a minute. So at this point, this port channel 1 is up and running between leaf 1 and 2. So next step is probably going to be, let's go ahead and create these layer 3 interfaces for VLAN 4094. So maybe we come back here. Get rid of these. Config T, interface VLAN 4094. Now IP address, we said it was going to be 999. Now maybe we'll drop out of here, come back. So on leaf 1, it's going to be 0/31, 0/31. And on leaf 2, it's going to be the other 1/31. On leaf 3, we can see here it's going to be 999.2.31, 231, and on leaf 4, 999.3.31, 331. Okay, so let's we should be able to try and just ping across these. See what happens. Thinking too much about it. So no problem to ping from leaf 1 to leaf 2. That looks good. We'll try the same thing on number 3 here. Ping 999. Yeah, this one's .2, we want .3. There's the other side. Okay, so I think we're good at layer 3 now across VLAN 4094 across the port channel. Let's look at this once more. We're still in 4094, show active. So let's come back here. Maybe I should put these other hosts away for the moment. Show active. So we could see there's our layer 3. One other thing we're going to want to do here is put, by default, these are in auto state, which means that the state of the interface, this virtual interface, VLAN 4094, is able to go up and down. Now, since this is a virtual, it's not like anyone's going to unplug the cable or anything. So we want this to stay up all the time. So there should be no reason we can use this no auto state command. Now if we show active, we'll see that's in the list. By using the auto state command, this will just ensure that this the state of this interface always stays up, because we don't want it to be the reason that the MLAG comes down or gets into a strange state. And the real concern there is that between the two, that they lose connection to each other and they both become active. That would be a problematic situation. So we want to make sure that this the state doesn't change on this virtual interface. All right, so we've got that configured. Now we're on to the actual MLAG configuration. So this is all the configuration needed to so that the two sides of the switches, the two leaf switches, can talk to each other in regard to their common connected MLAG interfaces. So now that we're in here, we can do a quick question mark and have a look at what the options are. There's a few in here, and you're going to need probably at least 4 of these. Certainly domain ID is one, so we'll start with that. Domain ID. And in our case, let's just call it MLAG1. That can be a string. It can be, it's a string field, so it could be a single number. It could be a couple of digits, whatever you like. So we have our domain ID. We need peer address. So that's going to be the address, the layer 3 address on the other side of the link. Excuse me. Peer, nope, peer, wow, peer address. So 999, and here's where we're going to have to be careful. Let's make this 1. We'll turn these off. Well, actually, this is the one that's going to be 1, so turn this one off. Leave this one. This is going to be 0, because again, it has to point back to the other side. So leaf 1 is 0, leaf 2 is 1, so we're going to put the opposite address in here. Now if we come down and deal with these, this one's going to be 3, and this one's going to be 2. Okay, so now we can open this all up again. Then we have peer link is another option. So in our case, you'll see we want the port channel 1, because that's the port channel between the two leaves. And what else are we missing here? We're going to want to set the local interface. You can see here. So, and this is going to be our, see it says VLAN interface. So local interface, VLAN 4094. That's set. And yeah, we'll stick with the standard everything else. So if we just do show active here, we'll see what we've done. Given a domain ID, local interface VLAN 4094, peer address is the address on the other side of the link, and the peer link is the port channel connecting the two. So that's that. Let's have a look then. So from a validation standpoint, we're ultimately going to do, the first command we're going to do is show MLAG. Let's have a look at it now, just for conversation's sake. So we can see here that let's drop out of this. Show MLAG. So we're going to see, here's our domain ID. We just set the local interface, the peer address, the peer link. You know, we just configured all of this. And we can also see the state of things. Active, peer link, local interface, this stuff is all up. So this is what we want to see. So what this means is that leaf 1 and leaf 2 and leaf 3 and leaf 4 are each currently talking to each other and ready to go in regard to having aggregate interfaces tied up where one port goes to leaf 1, the other port goes to leaf 2, and back to a host. So this is all the pre-work for MLAG. Now let's go back and have a quick look at the diagram. So really we've got leaf 1 and leaf 2 talking to each other and ready to deal with multi-chassis link aggregation. Now the next thing we're going to want to do is build this port channel going to host A, because this is going to be our first MLAG interface. And to show that we don't have any now, you can see down here under MLAG ports, all of this count down here is all 0. So we don't have any yet. Coming back, this is going to be port channel 11. It's going to be ETH5 on the 2 leafs. Come back to ports 1 and 2 on host A. So let's get on with this port channel 11 config then. So leaf 1, config T, interface, ETH5. So we're going to say on here, channel group 11, mode active. And then port channel, interface, port channel 11. And then on this thing, we're going to make a trunk out of this. So it's going to be switch port mode trunk. And I think we're going to just allow, what do we want to do on here? So, well, we'll call it, switch port trunk allowed VLAN 100. We only want VLAN 100 going down this to host A. So we'll do that. And then as well, we have to, since this is a port channel, and we only have one interface on this chassis connected in the port channel, how do we know, how do the switches know that these two are related? We're gonna have to give it some kind of name. So we're gonna say MLAG, and I'm gonna call this one 11 because of the port channel number. So we'll go with that. Now we're gonna do this exact same configuration on leaf 2. So let's come over here, config T. Well, just to prove things again, show MLAG. So we'll see, we still don't have it. What do we have on this side? Maybe this will say. Okay, so here we go. So now we have one configured interface under MLAG. Now it's configured. If it were more than just configured, it would show up under active partial or active full. It hasn't, so we have more work to do. So let's come over here to leaf 2. We can see this is not aware of anything because we haven't configured it yet. Interface ETH5. Once again, channel group 11, mode active. Then we're on to port channel interface, port channel 11. And this is going to be switch port mode trunk, switch port trunk allowed VLAN 100. And then we're going to go with the name MLAG 11. So this should now tie in. And now if we do show MLAG, what do we get? Okay, so now we have inactive on this side, and probably the same over here. Okay, inactive. Now you're going to wonder, why is it inactive? And I'm going to bet that at this point it's because the leaf sides are configured, but the host A probably doesn't have any port channel. So if we do show interface status, let's have a quick look at what interface is on here. Okay, so there's a port 11. There's port channel 11. What's the story with that? Show run int PO11. Aha, okay, so port channel interface exists and the description's there, but that's it. So we're going to need to configure the port channel here. And again, config T. This one's going to be switch port. Oh, whoops, interface PO11. Switch port mode trunk. Now we don't really need to restrict what VLANs there are because it's handled at the other end, but we could do it here too. Trunk allowed VLAN 100. Okay, so now if we do this show the interface status, okay, we still have not connect. Let's come out of this. Show run int PO11. 11. Okay, so this side doesn't really need to worry about the MLAG part of it because as far as it's concerned, it has the two interfaces. Oh, you know what? That's probably the other piece we're missing. we configured the port channel, but likely ETH1 and ETH2 are not in the... We could do two things. Again, we could do show LACP peer. We don't see anything, so we know we're nowhere close to having that ready to go. Or we could do show port channel and no active ports. So we see we have a port channel 11 and no ports. So show run int ETH1, for example. Yeah, there's a description on there, but it's not joined to the port channel. So config T interface E1 and 2. No, we just need channel group 11 mode active. So now let's rerun those show LACP peer. There we go. So we got ports 1 and 2. This state is as good as it gets. Now we can do show port channel. Here we go. Active ports 1 and 2 under port channel 11. That looks good. Now if we come back and look at one of these, show MLAG again. Now we can see here we've got active full on this. Or the other command we could do is show MLAG interface. And here we are with that's up, meaning both of the links are up in port channel 11. So it's full on. That is that. And I've got that done on, well, we'll see the same thing here. Interface up port channel 11. So one last look back here. So host A is now tied. This VLAN 100 is extended from host A up to leafs 1 and 2, and that's built over an active MLAG. And again, the benefit of that is, well, the benefit of this port channel over just having two links in VLAN 100 is that Spanning Tree would normally shut one of those down. If we have it in a port channel, we have that full bandwidth available, 2 gigs. And just to prove that, show int status, we'll see here that this port channel 11 shows speed 2 gigs, as does our port 1 link to between leaf 1 and leaf 2 for the MLAG peering. So, well, this is all off to a good start. One last thing I guess we could do is we come to host A, give it a, so if we do show IP interface brief on here, we've got nothing. So we know VLAN, well, let's see, show VLAN. We have no VLANs. Config T Yeah, I think we also didn't create the VLAN 100 back on the leaf switches either. So VLAN 100, and let's do interface VLAN 100, give it a layer 3 interface, IP address. What did we say that was going to be? So, oh yeah, this is going to be this 666.11/24. 666.11/24. So what we could do here, we could try and ping 6661, which doesn't exist, but it's going to send out ART requests. And now if we come back here to leaf 1 and look, well, actually, show VLAN. We don't have a VLAN 100 yet, so let's configure that. Config T VLAN 100. Name, we'll call this hosts AC. And let's do that on the other side. Let's look once more. So yeah, now we see host A is on the port channel between leaf 1 and leaf 2, and it's also on the MLAG port channel 11 down to host A. So just once again, if I do this ping, the ARP's going to go out. The MAC should be learned on leaf 1. So show MAC add VLAN 100. Don't see it. Show IP int show IP int brief. Okay, so that's up. I'm thinking that if we're pinging this, well, maybe because of the MLAG, it's coming on the other channel. So let's finish this. Let's config T VLAN 100 name hosts AC, because in the end we're going to have both on there. Show VLAN, same thing here. So now we have VLAN 100 seen on both of our aggregate ports. Show MAC add VLAN 100. Nothing. So let's ping once again. This should end up over here. There it is. Okay, so now we have a learn MAC. And again, this is the one coming from, yeah, it's seen all around now. So that's the layer 3 VLAN 100 MAC address that's now learned up here on leafs 1 and 2. So as far as our layer 2 goes, we're all good. We have this address here. It's able to, the MAC's learned all around in leafs 1 and 2. So the next steps will be to do that same config to build this out for, well, 2 parts. One, we've already got the MLAG peering between leaf 1 and leaf 2, and we completed the MLAG in total between host A and these 2 leafs. Next step will be to do the same for host B, which will involve VLAN 200. Then we'll move over and do the whole process once again across between leafs 3 and 4. So I will, I'll take a moment, go off and do that, and then we'll come back and continue.
2 hours later.
All right, now I've gone off and configured the rest of the MLAG on leafs 3 and 4 and all of the layer 2 connectivity between the hosts and the leafs. So let's go have a quick check that that's all that's all good. So I guess let's start on, what do we want to do? I guess maybe we just generate some traffic, or we just go to each of the hosts. So host A, show LACP peer, that one's good. Host B, show LACP peer. Oops, that one's good. Show LACP peer. Good, and here we go. Okay, so I guess we just generate some traffic out of each of these. Well, we've already checked. Well, let's do it once more. So we'll run this 6661. So on host B is going to be in VLAN 2. So we're going to ping this 777's addresses. So let's ping 777. Sure, whatever. We just need to generate some ARP requests and get the MAC learned. Ping 666.1, sure, and on D, ping 777, whatever. Okay. Now if we come back to these two leaves, we can do show MAC add VLAN. Well, actually at this point we don't care. Let's see all of them. So we see a MAC in 100 and 200, and we can see the 100 VLANs learned from port channel 11, which goes to host A. VLAN 200s from port channel 12. So we should see this all along the path here. Show MAC add. Once again, we have a VLAN 100 and 200. Let's go on to number 3. Show MAC add. Same story, 100 and 200. Now we'll see these are different MAC addresses on this side because from VLANs 100 and 200 only exist. They exist separately on both leaf 1 and 2 pair and on the leaf 3 and 4 pair. So there's no way that these can ping. Let's just finish this. There's no way that these will be able to reach each other currently, because if we come back to the topology, there's no layer 2 connectivity. VLAN 100 over here has no connection back to leaves 3 and 4. So that's what we're going to do with EVPN in the next steps, are to extend layer 2 over this layer 3 routed network between the two sets of leaves, and all these hosts should be able to speak with each other. I also want to show that the MLAGs are all working, although because we just did the search for the MAC addresses and see they're all learned, we know that that's likely working, but I neglected to actually show that. So let's just do that on each of these. Show MLAG interface. So here we go. These are the two port channels. The MLAG port channels on leaf 1 are good. Same thing, show MLAG interface. Same story here. Host A and B coming back to number 2. Now on leaf 3, show MLAG interface. We have host C and D coming back on the two 11 and 12 MLAGs. We should have the same here also. Show MLAG interface. And there we are. So just wanted to make sure we covered that the MLAGs are all working. So for our next steps, we've got all this layer 2 working, or the MLAGs in layer 2 are set up. Now we get on to building the underlay network for this EVPN and VXLAN in order that we're going to bridge the layer 2 using EVPN and VXLAN over layer 3 via the spines. So since we can see here, we've got a lot of interfaces with a lot of addressing. The important bits are we're going to make all of these routed links between the spines and the leaves. So those are just /31s because we want to economize on the address space we use up. Likely this would be private addressing, RFC 1918 addressing in the real world, but just for illustration purposes, it was easier to use some simplified addressing like the 55s and 55s and such. So we're going to use that here. And again, yeah, we really just have to address all the interfaces on the spines, between the spines and the leaves. We will use the /31 point-to-point subnets for that. The next important piece is going to be, we're going to put these loopback addresses on. So the spines will have loopback 0. So will the leaves will have a loopback 0. Again, this is going to be for the underlay network, or the goal of this next step is going to be, from a layer 3 standpoint, to make sure that all the loopback addresses can reach each other, because we need that underlay network to be working with the loopback 0. Then in subsequent steps, we're going to come back and get on with the VXLAN part, and well, we'll see. That's a different animal. So we'll cover that shortly. Let's get on with configuring the layer 3 and routing between the spines and the leaves. So again, the primary purpose of this is to make sure we have IP reachability between these VTEP loopback addresses and all the loopback addresses. This underlay network is going to be just on the global VRF, the default routing instance on all of these switches. Of course, we're going to need to enable IP routing, so we won't forget that. Another suggested item is there's a command about service routing protocols model multi-agent, which I think if we have a look at, yeah, see, I didn't put this in. This was enabled by default on the version we're running here on these virtual EOS. So if I show version, we see this is 4.32M, and by default, I didn't configure it. It was there from the beginning, this command. But I think on older versions, you would need this to be turned on. And again, not for this step we're doing right now, but in the long term to make all of this work, you're going to need that one. So we'll just get it done now while we're enabling IP routing, because as you can see here, by default, IP routing is not enabled. There's one other thing to point out at this point regarding the IP routing. So for our underlay network, we just need to tie these together, the leaves and spines together, with a routing protocol. So we could use any interior gateway protocol. So OSPF, ISIS would be fine. That would actually probably simplify things in our small system we have here. But for discussion purposes and for practical exercise, we're using eBGP, and we have 3 split ASs. So we're actually routing between autonomous systems here, and this will give you a good example of scalability and how this would work. Or this could scale to be quite large, and if you learn this in a situation, you should have no need for the others. So, all right, so we'll get on with configuring these interfaces. We might as well start with. Okay, so we'll just get on spine 1, and it looks like we have ETH 1, 2, 3, and 4. And then those have the subsequent subnets 555 or 55.1.0/31. Then the next one 2/31, 4, 6. So on 1, 2, 3, 4. So we should be able to go through and do that rather quickly. Let's pop over here, and again on spine with 1 and 2. Maybe we'll do this. So we'll just work on spines 1 and 2. Config T. Interface E1. All right, now we'll drop out because we're off and running. So we want IP address 5.5.1.0/31. Oh, never mind. No switch. Now the IP address. Okay, so we're going to have this all along the way. So 1, 2, 3. Let's do this on number 2. No switch. Then the address. This is going to be 2, 3, 4. Oops. 4. Yeah, no switch, and then the address is going to be 6. Okay, so we should be done with this one. Show IP int brief. What have we got? All right, there we go. And that should match with what we are expecting. 10121416. 0246. Yes. Now I guess we could put the loopback on here while we're at it. 5555 1.1. All right. Config T, interface LO0. 55551.1/32 because it's a loopback. Let's do no shut just to make sure. And now let's have a look. Okay, so now we have all of our addressing on spine 1 switch. Let's go on to 2. So no switch port, IP address. And now this is going to be just the same, but with a 2 in the third octet. 5.5.2.0.31. Oops, 4.31. And number 4. 6. And we'll do the loopback while we're here. Interface LO0, 55, 55, 2.2, I think. Oops, IP address. 32. All right, let's check that. So we have 2's in the third octet. 2's in the third octet, 0 through 6, and 5555 2.2. Okay, so it seems that our spines 1 and 2 are configured. Now we're going to go down through the leafs and make sure that they get configured as well. So on leaf 1, it's just going to be the odd numbers now. So on 1, the last octet is 1. 2, the last octet's 3. On 3, it's 5. On 4, it's 7. So it follows that pattern. We'll do the same. So let's go leaf 1, config T, interface E1, no switch, IP address 5.5.1.1 31 1. Let's go for it here. So then E2, no switch port, and then this one will be 2 in the third octet. Now we can try pinging now. Ping 5.5.1.0. That works. So that's the spine 1, and then we should go for .2, which is, never mind, it's 2.1. That's spine 2. All right, that's good. So those 2 links are all set. Now while we're here, interface loopback 0, IP address. Now this guy's got, I think, all 1s, 32, because this is leaf 1. No shut on this, and then we might as well do the VTIP. Yeah, interface LO1, IP address, and then this is going to be, oops, 111. Come on, 32. No shut. All right, so show IP interface brief. So on this thing we have the 2 links to the spines. We have loopback 0 and loopback 1. So let's go check our work. 5511, 5521, all 1s, all 111s. Oh yeah, oops, this loopback should be 32, I see. So config T, interface LO0. Should we have it here quickly? It should be a 32. Okay, well, let's check our work right here. the loopback should be 32s, these should be 31s, that's that. So the other thing I might want to do, it's not going to have any problem in this lab, but because we're doing EVPN and VXLAN, all that Ethernet traffic is encapsulated, so your normal 1500 MTU is now going to get wrapped in a something like 50 or 54 byte header. So you're going to get over 1500 bytes on a full-size packet. So maybe just for thoroughness, let's take care of that here. Ethernet E1 and 2, MTU 9214. Let's just go that route. So if we do this once more, yeah, these are now full size, because again, these are the links to the spines, so these are going to be carrying the potentially the encapsulated Ethernet packets, which will be over the normal Ethernet MTU of 1500. We probably should have taken care of that on the spines as well. Let's just do that. Config T, this will be quick and easy. Interface E1 through 4, MTU 9214, Control Z, write it. Show IP internet brief, or interfaces brief. So we got 9214 on all of the leaf connections. That's good. Let's do the same here. Exit interface E1 through 4. 9214. Let's go crazy. Show IP int brief. So these all look good here. And now we'll just keep on down the line. So off to leaf 1 is done. On to leaf 2. E1. No switch. IP address. Check. Let's quickly remember this one. Okay, yeah, so this is just going to be 3. So all the odd numbers, that's right. 5.5.1.3, 31. E2 will be the same, but we're going to change the third octet to 2. Then we're going to get on with loopback 0, 2, oops. Now loopback 1. Oh no, never mind. This one's going to be all ones as well. Now, this is going to seem a bit weird because, wait, didn't we just put this address on leaf 1? Yes. It's going to be here as well because in the grand scheme of things, we want this for redundancy purposes. So just while we're talking about it, we can see here this loopback 1 or hello 1 is the same address on both of these, because both of these are going to act as this VTEP once we get things rolling. The destination can be either of these for redundancy purposes. It'll work either way. The idea is going to be we're going to have a full mesh of paths, and there'll be lots of options from a routing standpoint to get from point A to B, and any of them are fine. So we'll so that destination with all ones could be either leaf 1 or leaf 2. It's all going to work out in the end. But yeah, we're not crazy, or we're not making a mistake by putting the same address on both loopback 1. We want this VTEP we want it to work either, regardless of which leaf catches the traffic, or again for redundancy purposes, if leaf 1 is down, it's all going to go to leaf 2 anyway. So, but the addressing will be uniform regardless. The same thing is true over here on in this VTEP. So we have the all 2's address on loopback 1. All right, just to point that out, let's come back to config. So this should do it for leaf 2. Show IP interface brief. Oh yeah, we got to add the MTU stuff. E12 MTU 9214. There it is. So that's all fine. Let's go on to 3. E1, go switch, IP address. This should be 5.5.1.5. It's going to be the next odd address. 31, E2, no switch. This is going to be 2.5. Then we're on to loopback 0. IP address on this one is 3s. No, we didn't do the NTUs again. And maybe I'm just trying to, well, all right, we'll handle that in a minute. So, well, while we're here, MTU 9214, why not? Come on. LO1. Doing that. 9214. Wow. E12 924 show IP int brief. Oh, that's right. Never mind about the loopbacks they have. They can get as large as they want already. Okay, so that's set onto leaf 4. E1 MTU 9214, no switch, IP address 5.5.1.7. That's correct, 31. 2. Okay, so I think we have our layer 3 links between the spines and the leaves all configured, and we have all of our loopbacks addressed. So why don't we, maybe the easiest thing to do is just go to spines 1 and 2 and see that we can ping the far ends on all of these. And that should be our validation. So let's go back to spine 1. Ping 5.5.1.1. So it's going to be all the odd numbers. That's leaf 1, leaf 2, leaf 3, leaf 4. Okay, so those are all good. On to spine 2. This will be the same story. Ping 5.5.2.1, leaf 1, leaf 2, leaf 3, leaf 4. Excellent news. So those are all up and running. Okay, so we've got the layer 3 interconnectivity done between spines and leaves. The next steps will be to get our BGP routing protocol running between these ASs. All right, for our BGP configuration, we're going to have both eBGP and iBGP. So the eBGP will be on the links between, they'll be pairing between the ASs, AS55 on the spines and AS111 and 222. And then as well, the leafs themselves, or for example, leaf 1 and leaf 2, will peer with each other in order that they can exchange routes as well. Since those are within this AS, they're going to be IBGP, and the same is true between leaf 3 and 4. So with that quick description, let's get on with the configuration. So come back to, here we go. The first thing we're going to have to do is we'll notice that, well, let's just look on here. We'll see that there are no learned routes. Show IP route. And we have nothing but directly connect. IP routing is not enabled. We can do the same command down the line here. Boom, boom, boom. All direct connect. No IP routing enabled. Same thing for all of the leaves. So we're going to get underway with some routing protocol. So if we start on the spines, I guess, let's start there. The very first thing we want to do, well, we want to do it for all of them, is we're going to want to enable IP routing. So let's just pop over here, config T, IP routing. Okay, so that's out of the way. Again, I guess if we're going to configure, let's do the spines together since we're at it. So we know we're going to need, the two spines are going to belong to AS55 and it's going to be BGP. So we're going to use the router BGP 55 command. So router BGP 55 and we're underway. So for these, we're going to want to change a few of the default items. So these are the high-level BGP commands. So we want to override, by default, BGP default is going to be IPv4 unicast. We don't want it to just join or peer up with anything. Well, and again, this is not so much for the lab use, but more likely you're going to see this in a production situation. So we don't want to just peer up with any IPv4. We're going to have to specify the neighbors. Unicast. What am I missing here? No BGP default. Yeah, IPv4 unicast. There it is. Another item we're going to want to change, again, not for this lab because this is all Arista to Arista peering, but if you're going to peer with Cisco, for example, there are some differences in the BGP cost. So we're going to, in the distance, default distances. So we're going to use that command here, distance BGP. We want to set this to be, we want the BGP learned routes to be distance 20, where by default on Arista, I believe they're 200. So again, this isn't really for this lab, but this would be for an interoperability situation. So we'll just get that out of the way. We want to also set, let's come back and look at the topology. There are lots of ways to get from leaf 4 to leaf 1, for example. So we could go via spine 2, we could go via spine 1. And so normally BGP is going to handle, it's only going to add one route to the route table because it's just going to add the best or anything of equal best cost. But in our case, we want to use any possible path, because again, we can now get more bandwidth out of this because we can use 2 links instead of 1 or multipaths. So we want to use the equal cost multipath option or have all of those routes show up in the route table. So for that to happen, we need to set the maximum paths command. I'm going to say 4 here. That's more than we need, but that will handle. I don't have to think too much about it in this lab, so we'll just go with 4. Nothing's more than, I don't think we're going to have 4 paths. In fact, when we just looked, it looked like there were maybe a max of 2 based on the number of spines you have. Now, so I think that gets the generic config out of the way. So we should get on with adding neighbors. So we could list out the neighbors. Well, let's go back here. So, you know, we're going to have all these leafs as neighbors. So there's going to be a lot of manual work if we want to just list the neighbors individually, and it doesn't scale well that way either, because if you, let's say you add more leafs later and you follow a similar addressing scheme, you could have them just appear, they would just show up automatically. So let's try and go that route. So in our case, well, we can see here that everything we've got starts with the 5.5, and we also can see that they're either 5.5 and 1 in the third octet or 2 in the third octet. So for planning purposes, this wasn't too great, because if we want to define a prefix that includes 55.1 and 55.2, there isn't one that conveniently fits just those two. So we're going to make it a little wider than it needs to be. So for example, probably 5.5.0/22, I guess, would get us 0 through 3 in the third octet. So let's go with that. So we're going to say BGP listen, I think it is. Yes, well, let's see how. Yeah, listen, I see it right there. BGP listen. Then I believe it's range. Now we can specify our prefix. So we said 5.5.0.0/22. Should include all of those 5.5.1 and 5.5.2 peer addresses. We're going to say peer group here. We'll call this underlay peers, and we'll set a peer filter. Oops. And we'll call it leaf AS range. Okay, and then show active. It's a little weird in this small terminal. We'll see it here. There we go. And as a result of mentioning this peer group, it's also added it down below as a neighbor. So we'll have to come out and define this leaf AS range, so we'll do that before we're done. As well, let's one other thing that's recommended in the Arista documentation for EVPN-VXLAN is to set a maximum routes. In this case, in the lab, we're not going to be worried about that, but just for good measure, or let's just use it here, maximum routes, and they're recommending like 12,000. So we're going to have nowhere near that here. So that's fine. And we also want to, so this will get us peered up to the leafs, and we want to redistribute the connected routes like our loopback and such. So distribute connected, and we haven't activated this yet. We can, because I don't think it's going to try and peer up with anything because we haven't defined the neighbors. We're going to want the neighbors to initiate based on this BGP listen. So I guess we can go ahead and activate then. So let's just, so that's going to be address family IPv4. And then we're going to say neighbor underlay, activate. Okay, so, and we've done this on both spines at the same time. So that should be our initial config that we need. Oh, back to, we mentioned about this leaf AS range. We'll have to create this. Let's do that now. So we're going to exit, and then exit once again to get back to where we can create a peer filter. So peer filter, we're going to give it a name, leaf AS, leaf-AS-range. And then in here, we're going to define this. I think we can start off with, we're we're only going to have one element, so we can just start with this match AS range. So, because again, we didn't define which what AS of neighbors we want to match up with. So this peer filter is going to define what AS range we're looking for. And back to the diagram, we want to peer up with AS 111 and 222. So we're going to specify a range here, so we'll just make it 111 through 222, which isn't the problem in our lab scenario. But from a design standpoint, we may want to pick something maybe 101 and 102 as to make it a little easier for these definitions. And then we need something else here, result and accept. So we want to accept only from AS numbers 111 and 222. Okay, so exit this. Well, we can just exit the config completely. Show, run, let's have a quick look. So we have our peer filter leaf AS range that gets used down here. We can see we have just these couple of global commands set for BGP, and then this should match us up with with all of the leaf peers. All right. Yep. While we're here, let's just do show IP route, and we'll see we only have our direct connects again, and we can also do show IP BGP summary, and we have no neighbors yet. But we see that IP routing is enabled and BGP is running because we've got this header here, and we can see the router identifier is set automatically to the loopback address, and so the 5555 address, so it's 11 on this side, 22 on spine 2, and that matches up with what we have in the diagram, 11 on loopback on spine 1, 555522 on spine 2. So I think we have the basic config done on the spines. Let's now move on to the leafs. So as we see, we've already configured the IP routing. Now we're going to do router. Come on, BGP. And now this is going to be two different numbers. So on leafs 1 and 2, it's going to be 111. And on the other two, 222. So there we go. We've got that set. Now, the first thing we want to set on this side is, now don't forget this, we've got two loopbacks, we've got a bunch of addresses. So we're going to actually specify the router ID. We could have and maybe should have done that on the spines, but we're definitely going to do it here. Router ID. And so this is going to be different between each of these. And for reference sake, the loopback is going to be 1111, 2222, and so on, 3s and 4s for each of these. So we'll just drop the others out. So 1.1.1.1, lock it, 2.2.2.2, lock it, 3.3.3.3, lock this one, and 4.4.4. And open this up again. Off we go. Okay, so just as we did on the spines, we're going to want to set these few default settings, I'll call it. So we've just copied that right here. I'm going to use the multi-paste that should go into all of these. And there we have it. Okay, so now we're on to what we're going to do about configuring our neighbors. And I believe we're going to, since we just have the two spines, well, we could try something like we did up here with BGP listen. But again, I tried this once before and I had problems with it. And again, I think it's related to the fact that the spine is listening for neighbors to try to join. And if I use that same listen command on the leafs and don't specify a neighbor, I think then the leaf one will just sit there and listen. So, I don't know. I tried this earlier and could not get it to work. So we're going to specify the spine neighbors. The way that's going to go, and again, the neighbors are going to be different between these. And what I mean by that is, let's come back to the diagram. So if we're down here on leaf 1, the two neighbor addresses, or the neighbor address on spine 1 is going to be 5.5.1.0. The neighbor address on ETH2, on the other connection for spine 2, is 5.5.2.0. And then that's going to be different than, so leaf 2, 5512. So they're just going to increment all the even numbers. And then the third octet's going to be 1 for spine 1 and 2 for spine 2. So we should configure all the neighbors by that means. So if we come down here, it's going to be neighbor. Okay, and then, well, we know they're all going to start out 5.5. So let's drop out of this group config for a moment, because it's going to be easier. Okay. Let's go back to leaf 1, 5.5, and we know that for this one it's 1.0 for the neighbor. We're going to specify a peer group, because we're going to want to set some common settings for these. So let's use spines. Then the other neighbor is going to be on spine 2. There it is. We'll leave it with that because the peer group spine config we can do on all of them in one go. So let's just come over to the next one here. So we know the first one's going to be 1 for spine 1, and then since the last one was 0, this is going to be the next even number 2. Peer group spines, and this is going to be 2.2. Let's keep going. 5.5.1.4. Peer group spines. Come up, make this 2. And then the last 1.6. Group spines. Oops. Now let's make sure that didn't do anything strange. Nope. And then we want 2.6. All right, that looks good. So, oh, I see we ended up with this peer group we don't want. So let's, no, get rid of that. Okay. Now, these should all look about the same. Let's go back to the multi-exec again. So if we're here, show active. Oh, we don't need these two. So if we take a quick look at these, they look to be correct corresponding stuff. So then under the spines peer group, we're going to want to, we still haven't specified a remote AS for these. So we're going to want that, and again, that maximum routes command. So if we come back up and look at what we've done here, the leaf AS gets handled by the AS range peer filter, but we're going to have to define it on this one. So neighbor spines, and then so max routes, we said 12,000, and as well we want the remote AS. Remote AS is 55 for all the spines. Okay, at this point, well, yeah, I think, well, that defines the spine neighbors. So we'll keep on with this config, redistribute connected. And while we're still here, as we mentioned before, come back, we need to get the IBGP configured as well. So between leaf 1 and 2, leaf 2 and leaf 3 and leaf 4. So maybe we'll just take care of that neighbor right now. So let's come back. These are going to be specific for each one. So, or between leaf 1 and 2 and 3 and 4. So let's only deal with leaf 1 and 2 right now. So the neighbor that we want is, we'll just do by name because we're only dealing with one. And in this case, we're going to use the loopback 1 address, this all one, or the 111 address and the 222 address on loopback 1. So we'll set that in here, 111, 111. And remember, that address exists, is the same loopback address is on both sides, so that's fine. Oh, sorry, that's not the, oh, yes, we also need VLAN 4093. We're gonna start a new VLAN, never mind. We're gonna start a new VLAN with a /31. So this is strictly for peering between, IBGP peering between leaf 1 and leaf 2, and the same on 3 and 4. Man, I forgot about this. Yes, it's not peered to the 111 address, loopback address. It's peered to a similarly addressed VLAN 4093. So let's finish this while we're here. So in this case, on the leaf 1 side, the peer is going to be .1, and on the leaf 2 side, the peer is going to be .0. So let's drop out of here because it's just going to be easier to deal with it here. Okay, so this neighbor is .1, and we're going to have to give the remote AS, and that's obviously 111 since this is IBGP. We are also going to do that maximum routes command, 12,000, and in the case, since this is IBGP, we want to give the next hop self address. So, or yeah, it's the next hop is going to be the address across this IBGP connection. All right, now let's configure the other side. So on leaf 2, we're going to do the same kind of thing, except this is going to be 0. Remote AS, we need 111. We need the maximum routes, 12,000. And we need next hop self. Okay. So we've done a fair bit of config now for both eBGP and IBGP. Oh, well, never mind. We've only done it on leafs 1 and 2. So let's keep on. Let's do the same thing on these two. So neighbor, this one's going to be the same idea, where .1 on the remote AS is 222 this time. Max routes 12,000, and next hop self. All right, we'll quickly do that on here. Neighbor 0. Remote AS 222. All All right, so now we've got similar config on all of these. Let's drop out of here. Show active. So we'll see here that these look right for the most part. So now we're going to try and activate some of these. So maybe the first thing we activate is the IBGP neighbor, because that should see that come up, and we'll just see that peering happen first because that's sort of the simplest one. Let's pop out here again. So on leaf 1, address family IPv4 and neighbor 1 and activate. Let's jump over to 2. This is going to be address family IPv4 neighbor okay. So now let's see if that's done anything. Show IP BGP summary. There we go. Okay, so it's active. Interesting that the time shows as long as it is. And that hasn't come up. Let's do this thing here. Show IP BGP summary. Should run. Let's have a look. All right, I'm not sure why these haven't come around. Let's keep on. Let's turn up the spines next. So since we're already in this address family show active, we'll see that we've only activated that piece. We can also activate the neighbor spines. So neighbor spines activate, and this is on leaf 1. Now let's look at the BGP summary. Okay, yeah, see those popped up right away. So the 2 spine are established. So here's our AS55. These 2 neighbors, that's come up and that's all fine. Now, show IP BGP summary. Now here we see we've only got peering to leaf 1 so far in 111, and that's because that's the only one we've activated. Let's just go down the line. We'll also do it here since we're show active. It's the same story. Neighbor spine active and BGP summary. So there we go. Those have come up as well. If we come back to spine 1, we now have our 2 neighbors. You should probably see the same thing here on on spine 2, we've got the 2 leaf neighbors. So this is all going well. Let's keep on down the line here. So we might as well just go to address family IPv4. We should just do this at the same time for these. Neighbor spines activate. Well, and now let's prep this next one. So neighbor 222. This one's going to be 1. drop out. So on spine 1, we see we got all 4 leafs. Both ASs are represented. We should have the same thing on here, and we do. That's underway. And just to finish this up, let's go here, neighbor 1, activate. And on this one, it's going to be 0, activate. Now, oh, I never did the show IP BGP summary. So we're missing something on that IBGP. Not sure what. Okay, maybe. All right, let's drop out. IP BGP summary. Now, oh, I know what's wrong. We talked about it. We talked about it, but this VLAN 3093. Yeah, I was just about to say, I wonder if I can ping from the 111 to, well, here, let's come back. That's going to be our problem, is we don't even have those addresses set on either side. So, or we can easily see it show IP interface brief, and we don't have an address with all 1s and a 0 or a 1 in the 4th octet. So, or we can see here, here's our 4093 doesn't have an address. So that's not going to work. Okay, so let's just go down the line. This should be easily resolved. Show VLAN. It exists. It does not exist. Okay, so we're doing all of this. Let's jump back here. So on both of these, all of these, config T, VLAN 4093, name. Yeah, we're going to call this like IBGP peering interface VLAN 4093 description IBGP peering. Oops, IBGP peering. IP address. So now we'll pop out because this is going to be different for each of them. On this one, 0/31, and this one will be similar. 1/31. Now if we show IP int, or now show IP BGP summary, yeah, there we go. So now we have our established. So that, yeah, we're on the right track, or that's what we were missing. We hadn't configured the address yet. 0/31 on this side. Similarly, 1/31. Show IP BGP summary. Everybody's established. Okay, so now we have our eBGP and IBGP underlay networks are handled. Let's see what we're learning. So if we come back here, see, we can see this jumped up a bit now, where prefixes received and accepted. There were only 5, now we've got 9. So if we look at what's going on here, show IP route, BGP, what have we got? We've got a lot of things here. What we're interested in are primarily, because this is the underlay network, we are really interested in the loopback addresses being reachable. So the all 1s, 2s, 3s, and 4s. And then we need the VTEP addresses. Actually, this one. So this is the loopback 1. So we're interested in loopback 0 addresses, these 4, and the loopback 1 addresses, which are only common to the pairs of leaves. So we have the all 1s address and the all 2s. So that all looks good. So the spines are aware of those. Now, if we look on the leafs, we should have something similar. Show IP route BGP. So we see all but our own. So we're missing the all 1s address because we're on that leaf 1 now. And the same thing's true. We don't have a BGP learned route to all 1s, 111, 111. Now if we take BGP off, we'll see we have those routes because we're directly connected to those. And the same with the all 1s. Okay, so now I think, that should take care of our underlay network. We can try and ping maybe from the spines. No problem. This is going to be our test. So we need to be able to reach all of these from everywhere. Oh, and then another item to point out was when we looked at the routes, you notice that we have, for example, from the spine to 1.1.1.1, we have 2 different options in the routing table, one via ETH1 and one via ETH2. And this is back to that ECMP. So we have the equal cost multipath routing working. So we can take advantage of any of these paths. And that's why we configured that. So if we go down here to leaf 1, we should be able to ping 2.2.2.2. That's 3.3.3.3. Okay, yeah, so we could try it for all of these, but this seems to be, just look, show IP route, BGP, as long as we've got routes on all of these, we've got our underlay network handled. All looks good. Okay, so our next steps will be to, let's come back here. So yeah, now we have all of these networks are learned, all the leaf networks are learned on the spine, and then as well, they're learned on the other leaves in the other AS. So our eBGP routing is working, and we can use all these paths. So we've set the stage for the tunneling. And again, this is going to be, we went layer 2, tunneled over layer 3, using EVPN and VXLAN tunneling and encapsulation. Now we're on to the EVPN portion. And again, just to cover what that, or let's cover where we've been. So we have our underlay network working. We're using eBGP to redistribute IPv4 routes so that we can, from an IPv4 standpoint, all of these addresses are reachable from anywhere in the network. So, and where that's important is now we're going to have the overlay network, and the purpose of that is going to be, again, we have this VTEP concept where these 2 leafs form a single VTEP, or they each have this address. And the way this is going to work is we're trying to extend layer 2 over layer 3. And for example, host A has a layer 2 MAC address that's going to be seen across this port channel at both leaf 2 and leaf 1. And it's going to be learned in the VLAN 100 MAC address table. We want that then to be advertised. So again, as if layer 2 were extended, we have the need to learn MAC addresses and have some kind of destination for that, because it's now going over layer 3. So this leaf 1 and leaf 2 are going to then, once they have a learned MAC in the VLAN, are going to say, oh, I have the host A MAC address in VLAN 100, and I'm advertising it from VTEP, the all ones VTEP. Now that needs to be learned by leafs 3 and 4. If, for example, the host C in VLAN 100, if those two are meant to talk to each other, then we're going to have those MACs in that layer 2 advertisement. It's going to have to happen between the AS111 leafs and the AS222 leafs. That's going to happen using BGP, but not using IPv4, but using an EVPN route type. That's maybe not exactly the right word for it, but we're going to be advertising MACs, the relation between MACs, the VTEP address, and the next hop to get there is going to be advertised using BGP. And so we haven't set up that peering yet, and that's really the next piece. That's what we need to do now. So we're going to set up the EVPN BGP pairing, and again, that's not advertising IPv4 addresses, it's advertising associations between MACs, VLANs, and the VTEP destinations. So to get on with that, let's go to the spine. I guess we'll do this. Going to be a similar config on both spines. So let's get into multi-mode here. Close these. And so we're going to have peering again, but the peering will be between the loopback 0 addresses on the leafs. So that's the spine is going to peer up with the all ones address here, the all twos address, the all threes, and all fours. So similarly, well, let's just get into router, BGP 55, show active. So you recall what we did last time. We didn't specify the leaf neighbors specifically. We used this listen range command. We could do that here as well, but due to the addressing I chose, ones, twos, threes, and fours, that doesn't conveniently fit into a prefix. Well, the problem we're going to have with that prefix might be if we overlap a little bit, we're now into these 5.5 addresses. So again, maybe this was a poor planning from an addressing standpoint. And again, this is not anything like what you'd see in production. This is more for example purposes, but here we are. So the result of that right now is we're going to probably have two ranges listed in order to accomplish what we need to do. So, and you'll see here in a moment, we'll just do BGP listen again, range. Now, if we want to get all ones, all twos, all threes, then that's going to start in, well, we can start like this, the beginning of the range, and then say, like /6, I think, takes us from, that'd cover 111, and it would 222 and 333. So this will cover, but it won't get to 4. The problem with 4 is it's too close to 5, and we'd end up having both of those in the same range if we made this mask wider. So anyway, so peer group, just like the last one. This time we're going to call it EVPN for the peer group, and we can use the same peer filter because the AS numbers are the same. So we'll go with leaf AS range. So show active. Now we see we have that one. We're going to need one that covers the 4 range. So we'll just, well, we could actually put the /32, which I guess is probably the wise thing to do because we don't need it any wider than that. Same story here, peer group, EVPN, peer filter is leaf AS range. All right, show active. There we go. And now you'll see that because we mentioned the peer group EVPN, we also now have a neighbor EVPN peer group. We're going to want to put some settings under there that are common to all of the peers. So we'll start out with neighbor EVPN. One thing that we certainly want to do is we want to make sure that the source of this traffic is from the loopback 0. So we'll take care of that. We also want to make sure we have the eBGP multi-hop. So same story. We want eBGP multi-hop, and we're going to also specify a time to live. Nothing's going to go longer than 3 here. So again, this is related to the fact that we're peered up on the Ethernet address underneath, but we want to get to the loopbacks on the leafs. So we're going to have the multi-hop option. Well, and never mind. This multi-hop is related to the fact that the destinations are going to be the VTEP addresses or the loopbacks on the leafs, and those are certainly more than 1 hop away. And again, this is to facilitate the tunneling from leaf to leaf, where the spines aren't, they're not going to be terminating any of this traffic. All right, so we'll put that in. We're going to want to send the community, because you'll see shortly that there's some different config we're going to have for EVPN. Once again, we'll put the old maximum routes on here. And effectively, this is going to limit the number of MACs that are learned and advertised. I think that's all we need to get rolling here. We'll have to activate. So again, because this isn't the IPv4 family, so we're going to end up with address family EVPN, which, well, you'll see that's an option here. There's a few options. Previously we chose IPv4. This time we're going to choose EVPN. And now we had that group called EVPN activate. So I guess it's fine to start this, although there's nothing listening yet on the leaf side. All right, let's kick this off. We may get some error messages on the console or something here, but and we certainly won't have any peering yet. Show IP BGP summary. So that's our V4, never mind. Then what we really want to see next is going to be show BGP EVPN summary. You're going to want to remember that command. And now we see that command is working. And just to here we can try it on, we could try it on one of the leaves. We'll do that first to show that it doesn't work because there is no EVPN on BGP configured yet on the leaves, but it's up and running now on the spines. All right, so we'll leave that for now. We'll come back to that command next. So let's close these. We'll get on with the leaf configs. Config. Starting with the router. Oh, sorry, config T. Router BGP. Now again, this is going to be 111 on some of these and 222 on the others. We'll just get the framework built here. So for the leafs, we only have the 2 spines at the moment, so it's not a big deal to define the neighbors specifically. But once again, we're going to need the same EVPN common config. Didn't I do a show active? Maybe not. Okay, so we're just going to do show run. Let's drop out of here. Show run. That gives us all that. Let's jump back here. Shut these 2 down. Now if we roll back, we can see the common EVPN commands we have right here. So for this neighbor EVPN peer group, we're just going to copy the same stuff. So let's take these. We're going to use the exact same bits down here. Multi-paste. There they go. Now we're on to the neighbors. Now the neighbors aren't specific because for the EVPN, the neighbor on the spine is going to be the loopback address. So we're going to have the same 2 neighbors no matter which leaf, which is different from the IPv4 because we were going over the individual directly connected networks. So we had all these addresses to deal with. Now we're just going to deal with the loopback on the spines. So all the leaves can have the same config for neighbors from a EVPN standpoint. So neighbor 5555.1.1 is spine 1. Peer group, so we need to associate this peer group EVPN. There we go. Then we're going to do the same for spine 2, which is 2.2. Okay. And yeah, while we're at it, we're going to need the remote AS 55. Same is true for 2.2. Okay, now that should define all the EVPN BGP peering bits. Now we just have to activate it. So again, like we did, we're going to go for address family EVPN and then neighbor group EVPN activate. Let's see what happens now. So these things, oh well, I guess we can do show IP, show BGP EVPN summary. Here we go. So there's the only one that looks weird is this one. So we have leaf 1 is peered up to the 2 spines. Leaf 2 is the same. Maybe we just needed to wait a minute. No, there's the problem with number 4. So then you think, well, what's different about number 4? Back on the spines. Oops. Yeah, that's not working. Now, I think what we're going to find here is that this... anyway, let's just get out of here. come back here, show BGP, EVPN, summary. See, now we have the 4 loopbacks. So this all look good. What about same story here? Oh no, the problem was on this one. Show BGP, EVPN, summary. 1, 2, and 3. So we're missing 4. And again, there's the thing that's odd about the config for 4 is, remember, we 1, 2, and 3 all fall under this thing, and then the 4 should be caught by this one. So what is different on 2? Show run. Oh, wow. Okay, so we're missing that one. That's what went wrong. I think maybe I only edited on spine 1. Well, that's easily remedied. We just grab this, come over here, config T, router BGP 55, paste this in, and now, there it is. Okay, so that all looks good on 2, looks good on number 1. Then if we look at, I think it was what, leaf 3 and leaf 4. Yeah, leaf 4 was the only one. Now we've got it. Okay, so we now have the BGP routing for EVPN is ready to go for the overlay. Yes, so let's pop back here. Let's get out of config mode on these. So the stage is set now to do the plumbing for VXLAN and to map VLANs to tunnels. And we do have a little bit of routing to deal with for the EVPN side. Let's talk about that next. So that's only going to be on the leaves. What else should we look at while we're here? So again, show BGP, EVPN, summary. So the 2 spines see all the leaves. All the leaves see the 2 spines for EVPN purposes. Now, if we look at what we're learning here, I don't think the peering's up. So if we say, let's just get rid of the summary part. Yeah, we could see we're learning nothing at all, but it's up and running. So now we're on to, well, there certainly won't be anything learned yet because we don't have anything generating MAC addresses. Well, there's 2 reasons. One, we don't have any configuration to map VLANs to VXLAN tunnels to VTEPs. So even if we had learned MACs on the leaves, well, they wouldn't go anywhere. So, and we see we don't have any. Show MAC address VLAN 100, for example. So there are no learned MACs. It doesn't even exist on the spines, but we have no learned MACs. We're going to come back to that in a moment, but let's deal with the rest of the EVPN routing piece, which is going to be similar for each leaf in the AS. So we'll start with the leaf 1 and 2 in AS 111. So what we're going to do here, config T, router, BGP, 111. Now, there is the ability for a VLAN command in here. And here we see it. So there's a bunch of ways to do this. So we're just going to stick with the specific way to do this, or there's this bundling scenario, which you're likely to do if you have, large numbers of VLANs to deal with, or you have tenants, customers that have groups of VLANs and things. So you could do this bundle. That'll save you on the configuration part, or economize on the number of lines of configuration. But just for example purposes here, I'm going to be very specific. I only have two VLANs to deal with, 100 and 200. So we're going to deal with those specifically. So here we go, VLAN, and then we specify VLAN. We're going to go with 100. And now, what we need to do with this is define where we need a way of labeling these MACs. So again, it's going to be a route of sorts, or if you're used to dealing with BGP, IPv4 or IPv6, you're used to advertising routes. In this case, we're advertising MAC addresses and VLAN pairs, and they have to originate and have some kind of target to where they're going to go. So similarly, we're going to use like route distinguisher. So in this case, for VLAN 100, we're going to say route distinguisher is the, here, let's turn this one off because these are going to be different. So we're going to come from 1.1.1.1. So we're going to say route distinguisher is our loopback 0 address on leaf 1. And we're going to, I'm going to say 100 because that matches the VLAN. There we go. Now we're going to do something similar on number 2. So it's going to be all 2s without 100. Now we can enter this. The rest of it should be the same. So for the outbound traffic, we're going to say route target for export is, we're going to use the AS number. So this is going to originate from AS 111 and this VLAN 100. And then for the import side of things, for VLAN 100 on this VTEP, leaf 1, we say we want to import. The only other place they can come from at this point is from the AS222. Because if it's already in 111, we're already going to know about it because of the MLAG. We're already going to learn all the MACs in 111 in leaf 1 and leaf 2 natively, where there's no need for EVPN-VXLAN. So what we are going to want to do is learn the VLAN 100 MACs from over in AS222. So that's what this is about. So we're going to say we're going to import VLAN 100 from 222. And in order that we can actually send anything, we're going to say redistribute connected. So that should seem familiar. Okay, and let me look at this for a minute. That does seem like all we need for VLAN 100 in regard to the BGP redistribution. Now, yeah, so that should take care of the routing piece. We're going to have to do something similar on, well, actually, let's finish. We'll take this in 2 steps. One, we'll let this, I don't know, maybe not. Maybe just trying to decide if we should go ahead and finish just one side of it, then go ahead and, yeah, let's do that. Let's leave it like this. We'll eventually go to host A. We'll go to host A. We'll try and generate a ping to anywhere because that'll create an ARP request that should go out. The MACs will be learned in leaf 1 and leaf 2. And then next thing we're going to do is build a VXLAN mapping for VLAN 100 between AS 111 and AS 222. And at that point, then we'll see that the MAC, that VLAN 100 MAC is learned or seen up here on the spines. We won't see it learned at these two yet because there's nothing to import. They're not set up to import anything. So I think that we'll try that first so that we can see it kind of half working. Then we can build the other side and watch that go. Okay, so now back to our leaf 1 and leaf 2 config. As we said, we're going to have to create a VXLAN interface. So, well, let's look at one thing while we're here. So if I say show VLAN 100, of course, port channel 1 and port channel 11 are the only two places connected to VLAN 100. And if we come back to the diagram, port channel 1 and port channel 11. MACs can be learned anywhere around this triangle here, but those are the locally connected. Now, in the end, we also need VLAN to get bridged off somewhere else. So through what interface is that going to happen? It's going to happen through the VXLAN interface. So we're going to create that virtual interface. Now, config T, and it'll be the same on both leaf 1 and leaf 2. So we'll say interface VXLAN, and we can give it a number. So we're going to go with 1. And now we have options in here. Actually, we have lots of options. But once again, this is all going to be VXLAN related, so we're going to configure VXLAN parameters. This will start then with VXLAN. Source interface is what we're going to need to certainly define. Where do we want this stuff to come from? So source interface. We're going to say loopback 1, because if you recall, loopback 1 is the VTEP, or the address we want to associate with the VTEP. So we want the all ones /32 address between leaf 1 and leaf 2. So it's going to be loopback 1, done. We can specify the transport. So again, VXLAN, let's look at, we have a bunch of options here. So, we could see UDP port. It's obviously going to be UDP by the nature of it. But the reason you're going to say it here is if you wanted to specify a non-standard port. So the standard port 4789, I recall, we're going to state it here. And again, maybe this is good practice for interoperability reasons or just to remind you that there is a port set and used, and it may not be what you're expecting. So we'll define it here. Then the next bit, VXLAN, we're going to specify the VLAN mapping. So what we're missing here is we're going to need to, since we're going to send this out of VXLAN, we're going to need to map the VLAN number at this VTEP to a VNI that's globally usable. So, and again, that number can be quite large. For simplicity's sake, I'm trying to decide, well, I'm just going to keep it simple for the moment. So maybe we'll experiment on the next one. So VLAN 100 gets mapped to VNI 100, let's say. Okay, so that's done. I believe that's all we need. So let's drop out of here. We're going to grab some hosts. Let's go with host A. So here we go. Let's just start pinging this 666.1. Again, this will generate an ARP request as a starting point, which should, well, let's see. We should see a learned MAC. Yeah, there we go. So now we have a learned MAC on VLAN 100 from port channel 11, which is the MLAG down to host A. We should have something similar on number 2, on leaf 2, and we do, same MAC, learned on port channel 11 because that's an MLAG, it's on both chassis. So that's learned on both of these. Now, if we look up at the spine for EVPN, the only thing we see learned are these, well, if you notice the the type, this IMET. So this is a bit different than the association between MAC address and VLAN, because we don't have any learned MACs being advertised yet from the looks of it. But this IMET piece, this is related to BUM traffic, broadcast unknown unicast and multicast, the BUM. That traffic is going, well, is meant to just get flooded. So this is our flood list. So we're saying that, yeah, I guess we're advertising that we want to get flood traffic for VLAN 100, or sorry, VNI 100, and it's destined for either of these two, and the VTEP address is here. So that's all we see on the spines for EVPN. And now, if again, we have the basic config on for, well, let's look at here, leafs 3 and 4. Where did we end up with these? Show run. Yeah, we don't have any, we didn't do any of the VXLAN nor the BGP VPN mapping. So I guess we could take a minute and do that, because I'm thinking that's why we're not, we need to see more here. There's nowhere for any learned MACs to go. So that's maybe why we don't see it here. Okay, so we certainly know we have to do that config work. Here, why don't I just list it out here for reference. So we see the 1 bit is going to be this VLAN piece. The only difference here is going to be the import and export will have the AS numbers flipped around. And then this VXLAN, this will be exactly the same config. So let's just go to multi-exec. We're not going to deal with the spines. We're not going to deal with 1 or 2. We're just dealing with 3 and 4. None of the hosts are we interested in at the moment. And you can see this is still pinging, well, still sending ARP requests out from host A, so that we can use that as we go here. So if we scroll back, we know we need something similar to this on leafs 3 and 4. Let's go. Config T, router, BGP 222 this time. Show active. Let's see what we've got. We have everything except for the VLAN piece, so we're just going to add this bit right here. Except we're going to flip this around. Oh, and we're going to have to deal with the route distinguisher being different. So VLAN 100 is the same on both. RD, and this is the different part. So let's just change this. This is going to be on leaf 3 is 3, all 3s. 100. I'll just enter that one. Let's do similar over here. Go. Okay, now we're back to this mode. Route target. Import is going to be, we want to import from AS111 for 100 and export 222. And I thought we had a, you know what, I think, are we missing that? Didn't we say redistribute learned? Oh, that's not even a, why am I having this thought about redistribute? Yeah. Yeah, learned is an option. Okay, so so I just hit enter, show active. Okay, there it is. Maybe that's what we're missing. Somehow we don't have it here, but I swear I typed it earlier. Okay, so that's maybe what's wrong with what we were dealing with so far. Well, now we've configured it on the AS222. We haven't had any pinging here yet, but if we do show BGP, EVPN, aha, okay, so now we're seeing these is all IMETs. So this is again how we're going to distribute the bum traffic. Okay, let's come back, and we need to fix this one as well. So I think we're done with these. Let's go back here, and we're going to configure router BGP 111, show active. Yeah, we don't have on this VLAN 100, we're not redistribute learned. What's gone wrong? Oh, because I pasted it in on this side, I guess. Okay, this side should be good. VLAN 100. Redistribute learned. Maybe that's where it all went wrong last time too. Control Z. Should run. Redistribute learned. Redistribute learned. Okay, let's pop out of here. So we know on host A this thing's still pinging and nothing's happening. If we look at leaf 1, for example, VLAN 100, we have one learned MAC address, which is this one. And if we look at the spines, do we have anything? We do. Okay, so now we see we have a different type now. We were seeing only IMETs before. And again, this is related to the bum traffic redistribution. So yeah, we're still missing something. Well, anyway, so that MAC that's learned from host A is also being advertised up to the spines because we see it here. Now, we don't see it on, what about these leaves? Oh, there we do. Okay, we do see that MAC, and you'll notice that we have a number of ways to get there. So if we're looking for this MAC, we actually have four choices of how to get there. Now, and we probably have the same thing on here, and we do. Okay, so this is our one-way path. So we're making it, that MAC is learned and redistributed. So leaf 3 and 4 are aware of the host A MAC address. Now, we don't see any MACs learned. Here, let's go back to the diagram because let's put it together what we're trying to do here. So host A is in VLAN 100 off of these leaves, which is AS111 and this VTEP. That MAC, because it's sending that ARP request, the MAC is learned on these two leaves, and then it's advertised out over EVPN and VXLAN to leaf 3 and 4. And we see that that MAC is known over here. One other thing to point out is back here on leaf 1, I don't think we talked about this, but if I say show VLAN on here for 100, I don't know, yes. So we see our usual interfaces, port channel 1, port channel 11, and VXLAN 1. So port channel 1 is this, because this is an MLAG, you know, this anywhere in this triangle, those are learned, or the MAC is seen off all those ports. And then port 11 is the MLAG port channel itself. And then now there's a link via VXLAN to the rest of the network on VLAN 100. So we see that set up here. If we go look on 3 and 4, we should see something similar. Show VLAN 100. Okay, we don't, oh yeah, we never mapped the VXLAN. Okay, well, we haven't tried to ping back and forth yet, but even on Leaf 3, the fact that these MACs are known here, the advertisement is coming in from BGP for these MACs, but it's not going to be of any use because it's not tied. This is coming from the rest of the network, but we don't see the VXLAN entry here. So that's the next piece we're missing. So let's do that. Let's jump back here, close off these. We're only going to deal with 3 and 4. And once again, we want this, yeah, we're going to use this, we can use this as is actually on Leafs 3 and 4. So let's start config T, and we'll just multi-paste. There it is, Control Z. Now let's come back. Now if we look on, run the same command here. And now we see that because of this VXLAN interface exists, it's tied into VLAN 100 by this bit right here. And now if we show MACs in the VLAN on this side, show MAC add VLAN 100. Hey, look, we have a learned MAC that's come from the VX1 port all the way back on from this pair of leafs, or the host A MAC is now learned all the way into layer 2, or the MAC address table of VLAN 100 on the Leaf 3 and 4 switches. Okay, so I think we've got all the config done. Now the thing that's wrong here is we're pinging some arbitrary address, 6.1, which doesn't exist. If we look at host C, show IP interface brief, we can see we have the .12 address, and host A has .11, and that's just exactly what we see down here. So there's 11 and .12. So let's try and ping, and it ought to work. Let's ping 12. And there it is. Now, because that has answered back, we're going to see more MACs in this. Well, we're now going to see the MAC that's learned off of port channel 11 over here on Leaf 3 and 4. And there it is. So this must be the MAC on host C, learned from port channel 11. And we'll see something similar back here on, yep. So now we have this is the one learned from Leaf 3 and 4. Once again, let's have a quick look at the EVPN. So now we see in this list we have two sets of MACs, or two different MACs. We have the one that's our own, so we're on Leaf 1. This is the one from host A. And then we have 4 different paths to take to reach the one over on Leafs 3 and 4. And we'll see the opposite, well, or if we go back and look at now up here at the spine, show EVPN, now we see the two. Once again, these IMETs are handling the bum traffic, and these two MACs are learned, and there are 2 ways to get there. And again, this is like one of these is going to be for leaf 3, one's for leaf, well, sorry, this one, leaf 1, leaf 2, leaf 3, leaf 4. So to get to any of these MACs, you have 2 paths from either of the spines. All right, so now we have, so again, for this VLAN 100, let's come back to the diagram. VLAN 100 is good. We can ping between the two. It's all going via EVPN-VXLAN bridging. Now we can do the same thing for host B and D with VLAN 200. So that should be pretty simple to configure. Let's kick this off. We'll, if you recall the addresses, same thing, but with 777.11, 777.12. Let's just start pinging those from the start, and then we should see that go live. Ping 777.7.12 is the far end. Interval 1, repeat for a while. Host C. Oh, never mind. C's in the 6 range. There's no route, so there's no routing on this thing, and nor is there a gateway set. So I need this command on B and D. Again, just to clarify for all of us, B and D are in the 777 subnet VLAN 200. So if I go to B, ping the far end. Let's come back here to D. We're going to ping 11 is the far end from here. Go. Okay, so neither of these are responding currently. If we go back to E3, look at VLAN 200, we should have a learned MAC. We do. If we go to the other side, VLAN 200, we do have a learned MAC. So these are the VLAN 200 MACs that we should learn shortly. Now, what do we have to do to make those work? We are going to only have to deal at this point with, well, yeah, let's just do it. Config. We'll have to deal with both of these separately then. So interface VXLAN 1 show active. So if you recall in here, the way we set this up is we're just mapping a VLAN to VNI, and we'll just add another one. VXLAN, VLAN 200, VNI 200. Okay, so just by doing that, now we should probably be, oh yeah, let's look at this. We don't see any 200s yet, so let me show active. There it is. Oh, I know what. We're also missing so we've added it here. We need a VLAN 200 line under BGP. So router, BGP. This is 111. Show active. So here we see we have this VLAN 100 set. We'll just need something similar for 200. So VLAN 200. Gonna be very similar. 200. Same story for all these. Now, let's try this, show EVPN. There we go. So now we see here's our 200 and the 200 I met. So we have bump traffic dealt with, and we have this MAC that should be going out. So if we look on one of the spines, yes indeed, here we have these two VLAN 200s coming only from leaf 1. So similarly, let's just do number 2, big T. And we're going to add that one line to interface VXLAN 1. There's that. Router, BGP 111, VLAN 200. So this is going to be, oh, we can see it right here, RD 200. These will be the same. Now again, if we go off and look at the spine, now we've got two. So we see 200 from both leaf 1 and leaf 2. Same here. So that's all good. Those should be landing over here. Well, EVPN wise, we'll see them advertised. Yeah, here we go. So we have some 200s. Well, we've got 4 here, 2 here, or 4 and 4, what we expect. Now again, we haven't set up any, we're done with the VLAN 200 stuff on leaf 1 and leaf 2. We have to do the same on 3 and 4. And let's just do it here. 3 and 4, so we'll, let's go config T, interface VXLAN 1, show active. So this will be VXLAN, VLAN 200, VNI 200, router BGP 222, show active. Well, we're going to have something similar to this. VLAN 200. RD, then we'll deal with these separately. This one. The rest of this will be the same, so we just grab here, multi-paste. Now that's done. Yeah, see the pings just started up on VLAN 200. They just started going through. So that's that. And if we go off and look, well, we saw they were already learned here. The missing piece was that the VLAN 200 MAC addresses. We didn't have any learned MACs from. Interesting. There's some mistake here because oh, maybe at the beginning because we didn't. Just trying to figure out why, because this is the MAC from host A, but why is it in 200? What do we see back here? Yeah, we see 4 MACs. These two, these two, these two, and these two. So this all looks correct. I mean, it's not going to harm anything at the moment. I think it was a transient issue that led us to have these. Maybe what do we have on this side? Same thing. Oh, well, now this. Yeah, did we screw up the config somehow? Show run. What do we have here? Okay, 100 to 100, 200 to 200. Ah, I see what I did. The route targets. I needed to change the route target to 200. It's still 100 on both of these. Did I do the same on this side, or I must have? Show run. Yep. Okay, well that keeps it exciting. Config T, router, BGP, 111, VLAN 200. So we are going to need to 200. I think I'm still going to have to get rid of the show active. I think we're still going to have all of them. Yeah. So I got to get rid of the 100s under VLAN 200. So no to this. No to this. All right, now let's keep fixing these then. Show active. So these are incorrect. Let's just grab them from here. Then we're going to do a no on these two. Okay, that's straightened out. Still need to do it on 3 and 4. Show run. Well, or config T, router, BGP, show run, no, show active. Here's our problem. VLAN 200. So this one we're going to flip these around. Well, let me just take this. 200. Couple now. And we'll get rid of the 100s. And now the last. RVP. Just take what we need from here. Okay. Now, there's VLAN 100 looks correct. VLAN 200 looks correct. There we go. So now we have, port channel 12 is the VLAN 200 port channel. Everything's in the right place as far as the layer 2 goes at each switch. Yes. Well, we can just get rid of this and look at all of them. It's here, and VX1, 200. Yeah, this all looks correct. So, and then I'm sure this hasn't changed. Oh yeah, it would have. No, hang on. Oh, it's more a matter of where the bridging happens coming in. Yeah, where it all went wrong was here, let's go back and look. What are we seeing? Yeah, here we had 2 different MACs getting mapped to VLAN 200. Okay, well, we got it the right way around now. Show run. So here's a good look at the config as it is. Again, this is a bit laborious to do this individual VLAN mapping, or every time we add one, and you see the mistakes I made manually. This is certainly something that in a large scale, or for it to be scalable, is going to have to be dealt with some sort of automation or orchestration. And yeah, this manual configuration is mostly for familiarization purposes as to what actually goes on underneath. But often, if you're in a large production environment, there's going to be a management system that you're going to deal with to handle this provisioning and to do it without typographic problems and human error. So, all right, let's come back to this diagram. So yeah, right now, well, let's look once again to see that the pings, we should have all the pings, everything's working correctly. OC is not trying to ping anyone at the moment. This should actually be 666.12 or 6.6.611 is host A. So of course that works because host A is still pinging 12, which is host C. So every one of these is pinging now. We saw that all the learned MACs are in the appropriate VLANs, and there is no layer 2 bridging at layer 2 between leafs 1 and 2 and leaf 3 and 4. This is all happening over layer 3 using the EVPN and VXLAN